Alright children, now we will learn the next new method, that is finding HCF by prime factorization method or using the rule of divisibility. Now children, if you see this kind of thing, I feel you may remember that we have done this kind of calculative thing in LCM. Yes, you are exactly right. But we are going to use the same method but in a different way. I will tell you how. If you remember, in LCM, we went on factorizing the numbers even though if one of the factor is not divisible to the other. For example, I was using 2 if 40 is divisible by 2, and instead of 60 if there was 50, still I used 2 because I brought 50 down. But here in this method of HCF children, what are we going to do? We will still bring both the numbers together, but this time I will think only of the factor which is divisible by both. So I start with 2. So I get 2 20s and 2 30s. Again for this I need to think of a factor which is divisible by both. If I think, I get 5 as well as 2. So first I'll go with 2. I get 2 10s are 20 and 2 15s are 30. Now here children, I get 10 and 15. Now one of my number is divisible by 2 and other is not. So in such cases for HCF, you cannot take 2 because we need to think of only the factors which are divisible by both of your number. Think about 3. 3 will divide 15 but it will not divide 10. So I cannot take 3. Think of 5. Yes, 5 is the only number which will again divide 10 and 15. So I will take 5 2s and 5 3s. That's it. Once here the numbers are different and prime numbers in such a way that they cannot be further divided, your sum is over. Now all these factors that we have got, when I multiply that, I get the HCF. So this is also a very unique method, and children can make a very quick calculation by this method, and once they understand this very clearly, they will never forget or they will never get the HCF answers wrong. I will explain you few more sums from your My Practice Time 5 children. Hello children. So now I will be explaining you the sum from My Practice Time 5. Question number 1. This is the F1, that is 280 and 476. I bring it together. As both the numbers are even, I start with the even factor 2. 2 140s are 2 320 238s are. Again I could see a even number, so I again take 2. So I get 270 and 2119. Now 70 is a even number but 119 is an odd number, so I will not take 2 this time. Just check if it is divisible by 3. No, it is not divisible by 3 because when I sum up I do not get the sum that is divisible by 3. Then comes 5. 5 is not possible because the last digit of this is 0 but this is not 0 or 5. Then I move to 7. If I check for 7, yes, I get that both of my numbers are divisible by 7. So I start 7 10s are 70 and 7 17s will give me 119. So now here that is an end. One is a prime number and other is a composite number. So you cannot carry forward any of the division further by taking a common factor. So now the common factors that I got are 2 2 7. When I multiply that, I get the HCF as 28. Okay children, one more sum I'll explain you, that is the J1 from My Practice Time 5. Question number 1. Here I have 3 numbers, 1000, 625 and 375. So I start with placing all the numbers together first. Now 2 is divisible by 1000 but it is not divisible by these two numbers. So I need to skip 2. What about 3? 3 is not divisible by this. What about this? Not by this, not by this. So anyone, if it is not divisible, I cannot take 3. The obvious number that I think is 5. So I have taken 5. 5 200s are 1000. 5 125s are 625 and 5 75s are 375. Now again I could see all three numbers only divisible by 5. So I have again taken 5. 5 40s are, 5 25s are, and 5 15s are. Again I can see that all the three numbers are again divisible only by 5. So I have taken 5. 5 8s are 40, 5 5s are 25, 5 3s are 15. That's it. Now here comes the numbers which are all different, and two of the numbers are prime. So we need to leave our workout over here. So the only common factors that I am getting are 5 into 5 into 5, and the HCF is 125. Hope children you all have understood this method clearly.